Good morning, everyone. So we are 11:30, still morning here in the East Coast, afternoon and evening for those watching afar. So pleased to introduce our friend, former New Jerseyan from where I am, Joel Levitt. Who's the president of Springfield Resources, and he's going to be talking about the fundamentals of lubrication science for people who do maintenance. All right, Joel, it's off to you. Thanks for joining.
Thanks a lot, Josh. I made up that title. That's not really what this is about. So my challenge is, how do you teach practitioners lubrication painlessly? So we'll go to the next slide, and I'll show you the way we're going to do this. I want to take us to school, like, in the old days. So another slide. I've been doing this a long time, over 30 years. I've been training in basic maintenance management. I'm not like a lot of guys here that I've been listening to or experts in lubrication. I'm really interested in getting the fundamentals across to new practitioners. And, I write a lot of books, and most of them are really boring. I'll tell you that right out. So next slide. I want to sort of put it in a more fun kind of context, and we'll call this a drop of the lubrication body of knowledge. So you can go next. You know the three laws of maintenance. If it moves and it's supposed to move, lubricate it. If it moves and it's not supposed to, duct tape it. If it doesn't move and it's supposed to not move, paint it. Next. So what makes oil slippery? This is like I'm talking about at the very fundamental level. And if you want to move through a crowded area, there's a couple things that happen. One is you bump into people that so you're attracted to them. And the other is there's so many people in the way that you can't get through. So lubrication takes care of these problems. So lubrication is slippery because it holds you apart. And it's also slippery because the molecules are not polar, so that they don't attach themselves to other molecules. So go to the next one. Friction is the result, or what lubrication is trying to avoid. You rub one body, the force that resists the relative motion. Friction is something you can sometimes hear or feel. it increases as the load increases, and it's measured by this coefficient of friction. And you can see the little chart here that, rubber on dry concrete is 1, and lubrication, lubricated steel on steel is 0.05. So that gives you a relative look at this. Okay, next. So two bodies, even if they look smooth, are actually rough. So if you magnify it, you can see the little rough spots in there called asperities. And it's not good or bad. I mean, friction is not good or bad. In machinery, friction is bad because it causes the roughness, causes those asperities to chip off. A little bit of grease in there keeps the bodies from touching, so they slide by each other. The friction plummets, heat and dirt plummet. Now, good friction makes the world go round. Without it, tons of things wouldn't work. Tires wouldn't work on the ground. When you walk, you wouldn't be able to get forward. So next. I always talked about oil analysis, to my clients, and then I realized that there was two different things, oil and grease. And then I found out that oil and soap make grease. Now, I have to just explain something, that I make up stuff. So if anything I say is wrong, I misread the text, and I'm fully responsible for that. Anyway, so that's next one. So let's look at viscosity. High viscosity oils hold the two things apart, and the holding is strong. They're strong, so that they float over each other. Viscosity is typically temperature dependent. Hot is lower viscosity and cold is higher viscosity. Again, hit it, Joe. Yeah. Oil molecules are nonpolar and they slide by each other easily. The viscosity holds the things apart, and then it moves easily because it's not polar. Now, you might ask the question, honey is viscous, and why don't we use that for a lubricant? It also tastes great, but honey is polar, and the molecules get caught by each other, and they don't slip easily. So that's why we don't lubricate our cars with honey. Although, hey, maybe it would be a very sweet way to do it. So next. When you get less friction, you have a more reliable system, quieter, cooler running, cleaner, energy efficient, higher quality output, and it's happier machinery. So you can see the difference in the coefficient from 0.6 to 0.05. That's like 10 times less friction approximately. So that means that there's less heat generated. And next. There's other jobs. Your lubricant will take dirt out of the system and take heat out of the system, and then it goes through a filter, and then it goes through a heat exchanger, and then comes back in cooled and clean, so it keeps everything running smoothly. And diagnostically, you look at, is the lubricant removing heat and getting cleaned adequately? Next. We all know there's other jobs. One is to transmit power, protect against wear, keeping the things apart, preventing corrosion. And then when you have gas in the system, it'll seal the system for gases. Next. So why do good lubricants go bad? Mostly contamination or the wrong lubricant or under and over lubricant or leakage are the drivers. So next. We have cross-contamination when you put oil in an oil container that had a different oil in it, or open containers. We have, things like a blown head gasket will get combustion byproducts into the oil. So there's that, and there's excessive loading will push through the viscosity. Temperature will, what's the word I remember? I did read Sonia's book, and I don't remember the word but it burns the oil. It changes the properties of the oil. So those are some of the mechanisms. Next. Coking. Thank you. Now, the question is, and this is where I want to take the practitioners, is to talk about some of the solutions to some of the problems we talked about. One is the issue of explicit versus implicit tasking, and I'll give you examples of these. Clean to lubricate, making sure you're using the right kind of containers. The areas are clean, either sized correctly, and handling equipment is appropriate for the size, whether you're using drums or cans or whatever. So here's some of the things we can do. One, change, please. Now, in preventive maintenance, we have two fundamental kinds of task lists. One where you have, very experienced people, and you say to them, go out and check the air compressor. And that was what we would call an implicit task list. In other words, you have to have significant outside knowledge in order to do the task. And it's, well indicated for, like a power plant that has highly, long-term employees that have been doing this for a long time. It has some shortcomings in that each of the technicians will do something slightly different. If you were a fly on the wall, you'd see they'd be doing different things. But it's very common in maintenance task lists that the PMs are implicit. In other words, it'll say check the belt or check the bearing, but it won't really tell you what that means. In explicit tasking, it'll have a drawing or a sketch. It'll tell you, like, remove the cap, wipe the grease fittings, pump in, whatever, one squirt or two squirts, wipe it again, recap, and then repeat that 6 times for each of the Zerk fittings. So that would be considered an explicit task list. And that's one way to improve lubrication, is to have, specifications that are very, very explicit, so that everybody, if they follow that, they do the same thing each time, rather than, like feeling the vibrations of the day. And, if they like it, they do it. So next. We always talk about clean before you lubricate. So you don't want, I think the worst thing is to put a grease gun on a Zerk fitting that's not clean and then pushing dirt into the bearing. It's just like you're wasting everything, the labor, the materials, the bearing, everything gets wasted when you don't clean it. Some of the other things are the containers always covered? Are the same containers used for the same lubricant every time? And are they adequately labeled? And, the old style oil can is a traditional approach to that. to not that. Now you can go to a bunch of vendors that'll sell you integrated systems so that you can keep track of the color and the geometric sign and the covers over the fittings, so that you really have a clean movement from the storage to the machine. Okay, so again. So I beat my 20-minute mark, I see. I want to open up the floor just for questions. Now, this is an experimental approach to describing some of the stuff that we talk about in big words to people that maybe didn't go to college, and people that are, that we want to understand the stuff, but we'll never read one of the textbooks that doesn't have cool pictures. So that's what I'm trying to do. You can tell me if I succeeded in that, and certainly I'm interested in anything that you have to say about this. So back to you, Josh.
That's awesome, Joel. Like that is a say different approach, right? With it, trying to make sense of all this to the guy on the ground, right? The new hire that needs to go out and perform these tasks. I had one question, because I really liked your, why good lubes go bad, and then clean before you lubricate, right? And we find that sometimes, and we hear stories about new oil, right? New oil coming into the facility. We make the assumption that that's clean, right?
Yeah. I know where you're going with this, I think.
Well, so the question is it clean? Can we use it? Do we have to do anything with it?
Yeah. And that's really one of the things that we want to look at, because in a study done, it was pretty recently, they found that the new oil was already contaminated beyond the level which the SAE recommends for that kind of oil. And they were recommending to filter the oil before it's used. That seems like a lot of extra work, but I think that we might have to do that kind of thing, particularly if the drums are stored outside at any point in their life.
Gotcha. So in terms of the supply chain life cycle of that drum, coming in, if it's stored outside, a rule of thumb would be to run that through a filter. And I guess particularly like hydraulic fluids, right, where particulate contamination is very sensitive, right?
Yeah. But I just want to caution you, Josh. I'm not an expert in this. You've got people here that know like a million times more about that. So I talk like I'm an expert, but I don't know this stuff as well as anybody who's listening, probably.
Gotcha. Yeah, and I wasn't trying to challenge that. I just thought when those things came up, I remember hearing those things and thinking about those aspects, and the way that you've put this out, it almost seems like it's the makings of an infographic, right, for new hires that could be a day one pamphlet on just the basics of preventive maintenance type stuff. If you have any,
you're revealing my secret thing here. This presentation is the first step in a book on lubrication, all pictures. And it's part of my new series, Elements of Great Maintenance Management. and there's now 4 books in the series, one on, PM done this way and defect elimination done this way and quality, maintenance quality. So I'm thinking kind of globally about how I convey this stuff, because a lot of it was not learned in a classroom. Like we learned it, from doing it wrong. I was an electrician briefly, not that good at it, but industrial electrician, and I learned by being stupid. And no, I wasn't stupid. I was ignorant, right? I have to get that straight. Um, I learned because I was ignorant and I did stuff wrong, and then I didn't do that ever again. So, but that kind of information is hard to convey to somebody, except if you do it in a fun and entertaining way. That's the scoop.
Just hey, any questions out there for Joel? We have a few nice comments. Sonia, of course, your first slide about what you do in maintenance. So duct tape is always a good one. And some fans out there, Adrian saying nice presentation. And I think you've got something in terms of how to lay this out, right? And how to spell it out with the for the guy on the ground, right? And even Leston is saying it is unorthodox, but it can be effective, right?
Yeah, I'm shooting for unorthodox, I think.
There you go. Excellent. Any other questions out there? Any last words, Joel?
Well, what I'm finding, and I don't know whether you see this in your areas, the new kids that are coming in to maintenance, it's hard to sell people on maintenance to new people. It's not a glamour thing. But the kids that are coming in are very sophisticated as far as high-tech tools. Where they do not have the sophistication is in the hands-on experience of actually interacting with real things. In when I grew up, like every boy either was like fixed cars or they wanted to be able to fix cars. I was in the case of wanting to be able to fix cars. But there was a lot of kids that worked on stuff and figured stuff out, and so they might not have had the book learning, but they had the practical knowledge, which is missing today, I think. So my goal of this series is to substitute or to provide some of the basic things that will supplement their sophisticated use of the CMMS and the high-tech gear and everything else, which is totally fun. But if you don't know what a torque feels like an old mechanic would know the torque, what kind of torque you put on a nut, or how much lubricant to put in, or any of those kind of things. All the sophisticated stuff is going to be useless. So that's the goal of this kind of approach.
Yeah, I had 4 Jeep Wranglers, right? And a CJ7 and 3 Wranglers. So, and you could work on those, right? So I did, let's say, light maintenance, change the oil, rotate the tires, and if I needed to go to on a scavenger hunt to replace parts on a Jeep, you could do that anywhere, right? So you did those things. You had more access to equipment back then to do. I think today the other hindrance is that there's so much let's say, consumableism, where you and technological advancement in, it's very difficult for somebody to work on their car, right? To have access to these things with today's technology out there, right? So I think that could be one. One of the areas where we obviously have a gap, with the labor gap, right? And that labor gap probably starts with access to like trade schools, where they can get that hands-on, say formalized education before they end up at the shop floor, right, as an employee. So I think there's a few things that are funneling that. The disappearance of having that on hands-on experience.
Yeah, absolutely.
Okay. All right. Well, Joel, thank you very much. Very unorthodox, but awesome and presentation. I like where you're headed. I like the way what you're trying to achieve here. And we of course appreciate you sharing that with us on the platform on LRVS.
I'm happy to be here. So thank you very much, Josh.
Thank you. Okay, everybody. So, and how can we get in touch with you, Joel?
Smoke signals. My email address is up here. Website is maintenancetraining.com.
Perfect. And feel free to connect with Joel on the LRVS platform. He has a speaker profile as well. You can connect with him there. And again, thanks for sharing.
Super.
And thank you all for joining us.
Yeah, thank you. Bye-bye.